Okay, so the next thing we're going to talk about then here is intersection and union and what these mean. Intersection and union. Okay, so think about, remember in these Venn diagrams or whatever, and this is the intersection of those two. So like, if these are all people who like kitties, and these are all people who like puppies, then how would you describe the people in here? So how would you describe them if you're thinking about it? If you were going to write people who like what? Say people who like both, people who like kitties and puppies, right? People who like kitties and puppies. Right, so why am I going into this? Going into this to emphasize to you now that the key word here for intersection is and. So if you're on a test and you're trying to remember, oh man, is this intersection or union? I can never keep them straight. Intersection is the one that's and, because you could draw your little Venn diagram and like, oh yeah, this is kitties and puppies. So intersection is and. That's where they intersect. So the key word for intersection is and. And here is the mathematical symbol for intersection, which is that one. Okay? And intersection is the picky one. To make intersection happy, for example, you have to like both kitties and puppies. So I always picture like this sign here is like tweezers kind of with like a little hand, like pinching the little intersection part, like pinch the little intersection part kind of thing. So, I mean, honestly, whatever it takes to help you remember it, as goofy as it may sound, if it works, go for it. So that's going to be your intersection. Union, on the other hand, would look like this, right? It's the union of both of them. So the way you might describe this would be people who either like kitties, and what would you say? Kitties or puppies, right? So people who either like kitties or puppies, okay? So the key word here for union is or. The mathematical symbol for or is this one. It's also kind of like a U for union, is one way to think about it. Another way to think about it is, I always picture this is like being some like guy who's kind of shaking his head. He's like, I don't care one way or the other, just kind of exasperated. It's like, whatever, just whatever. But he's kind of like, one way or the other, I'm going to be happy. He just wants somebody to make a decision. So whenever I think about union and intersection, I always think about, like, you know, when you have family and you're all going out to eat. And you've always got one person who only wants to eat one place, another person who doesn't want to eat here, and it turns out, like in Waco, there's only like one place where everybody's always happy. And in my family, that's always Olive Garden. So we're always eating at Olive Garden because every time we try to pick something else, we're like, we just can't make a decision. So this kind of reminds me of my husband, because he's always like, whatever, I'll eat anything, just somebody pick something. So union is the guy who kind of throws his hands up in the air and he's happy with anything. Intersection is the picky person who won't eat anything unless it's, you know, Olive Garden. So, all right, now why does this matter? All right, so keep this in mind. Put this somewhere that you're going to memorize it. The reason that this is going to become important is you might have an example like this. You'll have, all right, something like this. You've got this interval from 1 to 4 intersected with the interval from 2 to 8. Now, I can't do these in my head. I just don't think that way, so I'm always real careful, and I write them out every time. So what you're going to do is you're going to graph each one of these, okay? So I'm going to graph 1 to 4. That's not a 1. There we go. Come on. I'm going to graph 1 to 4. And then I'm going to graph 2 to 8. So when you draw your graphs, be sure to kind of line them up so that like the 1 is to the left of the 2, is to the left of the 4, is to the left of the 8. Okay? So now we're going to graph 1, 4. Now these are parentheses, so that means I don't include my endpoints. So I'm going to go like this. And then on the 2 to the 8, it's a bracket, so that means I do include my endpoints. 2 and 8 are a part of that solution. Okay. So then, now what I want to graph is 1, 4, and 2, 8. So you can kind of think about this as like people who will eat dinner. It's like, I'll eat anywhere between 4 and 8, or 2 and 8. Whereas like my parents, if they're not like sitting down to dinner by 3:30, they think that we're going to starve. So that means that the only way to make everyone happy, like, and, remember, when people are picky, it's an and. So the only one to make everybody happy is that we'd have to eat when. If I'm happy anytime between 2 and 8, and they're happy anytime between 1 and 4, then the only way to make us both happy is to eat between 2, and 4. So as long as we're eating between 2 and 4, everybody is happy. You can also think about this again, because remember, picky, intersection, picky, intersection. Intersection is where these are intersecting. So if you kind of drew a little line straight down, this is where they overlap. Right? They overlap here in this section. So that's what our solution would be. So that's actually would be, if you saw this as a problem, what they're actually looking for is this answer, that we go from 2 to 4. And if they ask you to write that in interval notation, set notation, you can say, well, x goes from 2 to 4. It's equal to 2. It could be equal to 2, but it could never be equal to 4. And that's what the parenthesis means. Remember, the parenthesis means you can't be actually equal to. And then the bracket says that you can. So that's how you would write that up. Okay? Now we're going to do something really similar. We're going to write the exact same problem down, except instead of joining them with an intersection, we're going to join them with a union. Good? So if you weren't happy with the way you drew the graphs the first time, you're in luck, because you'll get to draw them again. And try to line them up really, really good this time. So 1 to 4. And then 2 to 8. So anytime between 1 and 4, not inclusive of the endpoints. Anytime between 2 and 8. And any of those times is fine. Okay. So this is kind of like my husband. He doesn't really care one way or the other as long as somebody's happy. So if I'm saying, I want to eat from 1 to 4, and someone else say, well, I want to eat from 2 to 8, Derek will say, well, I don't care as long as we eat sometime. All right? So as long as we eat sometime. So the earliest that we could eat to make anyone happy would be 1. The latest we could eat to make anyone happy would be 8 o'clock. So think about the guy throwing his arms up in the air saying, as long as somebody's happy, I'm happy. So as long as we at least solve somebody's requirements, meet somebody's requirements, then I'll be fine. So this is kind of as far out as you can go. So the farthest left that we can go up here, or either one, the furthest left that we can go is this 1. That's where the 1 comes from. We can go all the way to the 4 here. We say, well, I can keep going even further and go all the way to the 8. So that's where that comes from. And you just keep the same shapes. So we can go as far left as we can go is to the 1, as far right as we can go is to the 8. So that's actually our solution here. The union of those two sets is actually 1 to 8. So that's how we'd write it, 1, 8. And then the set notation x, it can be less than x, because that's where the parenthesis is, but it can be less than or equal to 8. And the equal sign is because of the bracket. Super fun, right?